Hi guys, today we're going to look at rational and irrational numbers. So first we're going to look at what is a rational number. So it can be expressed by a fraction or ratio a over b, where a and b are integers. So we did integers on the last topic. You can go back and look at that if you forgot what that is. So let's look at an example. So we have 5. So it says it's expressed as a fraction, so a over b. So a is going to be our 5. And any number, whole number, we can put over 1. So 5 can be written as 5 over 1. So this is a fraction, so therefore it is rational. If we had 0.3, although this isn't a whole number, we can turn it into a whole number as, well, not turn it into a whole number, we can write it as 3 over 10. So 3 divided by 10 gives us 0.3. So that there are two integers, so 3 and 10. So therefore that's a rational number as well. In some cases, like 0.33, and these little dots here just means recurring, so this is 3 forever. We can't just put it over a number because it goes on forever, but we do know this is the same as 1/3. So here we have an integer of 1 and an integer of 3, so that is also rational. So if they can represent as two whole numbers on top and bottom, then they are rational. So looking at what is an irrational number, so the main difference here is it cannot be expressed by a fraction or a ratio of a and b. So an example of this is our special numbers like pi. So pi is 3.14142 and it goes on forever and it's always changing. We can also have square root 5, so this is a third, and that's, if you put that in your calculator, it gives you 2.23606, and then it keeps going and it's all different numbers. So the hint to find if it's irrational is the decimal goes on forever without repeating. So there's no set pattern, it's always different. So that's the key sort of difference between an irrational and a rational number. So here's some examples of rational numbers. So like I said, we have special numbers. So we saw pi before. We also have the golden ratio, which looks like this, and that sort of equals to 1.61803 and goes on forever. And we have Euler's number, which also is just another special number. And then we have our thirds. So we have square root 8, square root 3, square root 97. You can have all sorts, but just remember, not all thirds, so not all square roots are irrational. So there are ones that are rational, and I'll put some down here. So if to check, you really have to see what they work out to be, because some of them will be rational, some will be irrational. And that's it, guys. If you have any questions, come see me.